Okay, welcome back. Again, certificate in electrotechnical technology, building and structures. Okay. Okay, now what I want to do is to let me just take him out a little bit, around a little bit for me. Okay. That's good. Okay. That allows us to be. What we're going to look at is power circuits, okay, today. And I hope you find this useful. Right, identify the different types of electrical installations and systems. And again, we're looking at installation, buildings and structures. And that's your main heading that you would look under, okay? Here, we're simply recapping what we've done previously, okay? So let me move back, make sure you can read it. And you have room for zooming in, I hope, all being well, okay? Now, outcome from this session, recognize different circuits, understand how motor control circuits work, okay? Now this is the ring circuit with a spur or number of spurs. Ring final circuits begin at the protective device and end at the protective device. You can connect joint boxes, fuse connection units and spurs in this circuit. Now there may be changes within the IE regulations into this respect, in the number of that you can take off. So make sure you refer to the IEE regulations for the current specifications and exactly the amount of units you can take off, okay? That is your responsibility. The radio circuit, okay, with radio circuits the cables begin at the protective device and end at the last socket or fuse connection unit. Okay, you may have seen this already before, so I don't need to take too long on this at all whatsoever. Okay. It's okay, I haven't got my teeth in just yet, but I'm working on it. Motors. When a three-phase induction motor is first turned on, there is a large short-term overload. This is because of the large amount of inrush current due to resistive effect of the windings, and because the induced EMF has not created a large enough induced current to oppose the supply. This means there must be some means of effective starting and under voltage protection. Let me step back a little bit. Okay. Now what is he saying? Simply saying here that when you first turn on the induction motor, there's a massive current insurge. Now that current insurge has got to go somewhere, or means or be controlled in some way. Okay. Four types of starting are generally used on three-phase induction motors: direct line starter, star delta starter, auto transformer starter, or rotor resistance starter. Okay, let's make sure we can go in so you can see these. Okay, pull back. Okay, good. Now, direct online starter. The direct online starter can be used on single or three-phase motors. There are two aspects of a direct online starter: supply and overload arrangements and on the voltage arrangements. Three-phase contactor. Okay, that is three-phase contactor. This is the most common type for motors smaller than 5 kilowatts. Only the contactor and its overloads are shown. The supply is connected via a contactor magnetic switch. The overloads are connected in series with the windings. Okay, and these are your overloads here. That is your main contactor point. That is your retaining contactor once you have started your direct online starter. Okay, and I think I've put something on this online already in regards to our direct online starters, but if not, I'm going to try and see that I put it up again. Excuse me. Now, overloads. The overloads can either be magnetically or thermally operated, as well as a combination of both. If there is an excess of temperature, then these may not be adequate because the motor that they are protecting may get hot even though the overload has reset. A further method is electronic. So what we look at is a thermistor, and this is the thermistor rod. Okay, resistance value 2.2 ohms, very small resistance. This thermistor. Rod thermistor, disc thermistor. A thermistor is fitted within the motor and is connected to a coil. The thermistor is a thermal resistor. Its resistance remains constant until it increases with temperature, positive temperature coefficient, or decreases with temperature, negative temperature coefficient. Okay, but this is what will protect your motor from overheating, because it'll react and break the circuit and preventing the motor from going into overheat or overdrive. Okay, let's get back a little bit, get further and get it fully in here. Okay, you can do that. And let's look at that from the view, full view. Okay, and let's move in. Okay, now thermistor controlled overload protection. This diagram shows how a thermistor could be connected in a circuit. Okay, and here is your PTC thermistor. Okay, it has a diode, of course, to ensure one directional current flows in one direction only. Okay, three-phase and neutral supply. Okay, signal lamp, and you have your transformer here. Okay, start switch, stop. Remember, your stop switch is in series with the circuit. Okay, that is your retaining coil. Okay, retaining coil, retaining contactors. Let me get it right, rephrase. Right, when the start button is pressed, the coil on the contactor and coil on the relay are both energized and will stay that way until the critical temperature is reached. The resistance rises with temperature, which reduces the current to the coil. On the relay connected via the transformer. It would then de-energize and release the contact, breaking the supply to the operating coil. It would only restart when it has cooled down. So when this thermistor gets hot, once it has tripped the circuit, you cannot reset the circuit until this has cooled down. So bear that in mind, okay? My pan back a bit, make sure I get it full in. Okay. 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 Now, I would recommend you in some cases drawing these circuits out because they're quite useful to know. Okay. Control and on the voltage protection. Okay. Again, start, stop your coil or relay, if you like, connected to neutral. Have a feeder net, retaining contactors. Okay. Three-phase and neutral supply incoming. The control circuit consists of an operating coil, a start button normally open, a stop button normally closed, a set of hold-on contacts, okay, a means of the overload breaking the circuit, okay. And that will go to your motor connections, okay, etc. Right. Let's just take you in and make sure we can get you fully viewed. Pan back out, okay. Okay. Well, what this is showing you now is start and overload switches. The start button is a normally open contact. It is pressed to start, not stop. The stop button and overload switch are normally closed contacts. The stop button and overload switch are connected in series with each other. Okay, and here is your connections, okay? When the start button is pressed, current flows through the made contact, through the coil and through the stop button and overload to complete the circuit. The coil attracts a contact and the contactor makes connecting the supply to the load. When the start button is released, the circuit is broken and the coil de-energized, breaking the contact between the supply and the load. The coil must remain energized even when the start button is released. This is done by the hold-on contact. Okay. So the hold-on contact is very important in your circuit. It maintains the supply to the circuit when you've pressed the start button. hold on contacts. Okay, now again here we're showing you stage by stage. Hold on contacts. When the coil is energized, a separate contact is made within the contactor. This contact is connected in parallel with the start button. Okay, and here we are. Okay. The start button is then in effect shorted out, and so the coil remains energized even when the start button opens the circuit. On the voltage protection happens here as well. If the overload operates, then the current in the coil ceases to flow and the coil de-energizes. The motor would be unable to restart on its own. The start button needs to be pushed to restart the motor. Okay. Make sure you can read this for yourself and sometimes it's worth drawing out these diagrams. Okay. Star delta starters. Okay. Direct line starters provide large starting current. This large current demand is costly to the consumer and creates difficulties for the supply authority. Star delta starters reduce the starting current. It connects the motor winding first in star and then in delta. Okay. And here we have our star delta starters. Okay. On a star delta arrangement, the windings are positioned at a remote control point outside the motor. One end of the motor is connected to the supply, the other end is connected to so that it shorts out, providing the star arrangement. Once the motor reaches full speed, the connections are altered to connect in delta. This connection is made via 2 bars of brass. So you would always start in star and you would run in delta. Okay. Okay, let's go out a little bit. Let's go ahead and just make sure we can see this. So you can draw this out if need be. Okay. Hand operated starter. Okay. This is your star delta starter. It will press down for start. Then you would flick it back up to run, and you set that in that state, and it will run. With a hand operated starter, there are 3 positions: off, star, and delta. The mid position is the off position. To start the motor, the handle is pushed down. This has connected the motor windings in star. When the motor has reached the right speed, the motor sound changes. The handle is moved quickly up through the position into the delta position. Okay. And here we have showing you a star delta starter as to how it works. Okay, here the motor has no supply, okay, at this point in time. Okay, and all we're showing you is the connections, okay, that makes the supply to the motor. Okay, and this is your wiring system that shows you how this would operate in that sense. Okay, okay. Now, bear in mind, it's a matter for you to look at this and look at the actual front connection that you will have been given when you actually look at a star delta starter, as some of you will be familiar with this. So be sure that you understand the concept of the wiring. I'm not going to try to go through this because you have to understand this in your own method of learning, okay, and your own learning style. So I'm not going to try to tell you how to interpret this. Look at it, see what you come up with, look at the following process, go back to the previous view if you need to, and look at how that has been done. Okay. Okay. Here the star delta starter. Here the start button has been pressed. Okay. So we're looking at the press button. A supply has been put into the main coil via M2 and S2 and the timer switch. The main contactor comes in with the contacts M2 opening and M1 closing. M1 is acting as a hold-on contact. At the same time, a supply is put onto the start contactor coil. This pulls the contactors in. The hold-on contact S1 closes and the start coil is held via the timer switch. The closed S2 contact and the closed R1 contact. The timer starts and the motor is now connected in star. Okay. And again, start delta started. Let me just make sure I come right back. Okay. Moving. And again, all we're here looking following on the process. When the timer has run its course, it operates a switch and the supply to the start coil is removed. The main contactor is still held on via M1. The current now flows through the timer switch onto the coil of the run contact through the now closed contact S3. The start winding cannot be pulled in as R1 is now open. To reset, the overloads would need to operate or the stop button pressed. The motor is now running in delta. Okay. And this is how the process of that function operates. So become familiar with that process yourself, the timer. Okay. Just come back a bit. Go in. I'm out of focus on that end. Make sure I can bring all the bits in together. Okay, thank you. Okay. Here we have an auto transformer starter. Okay. With this type of starter, the motor is permanently connected in delta. The reduction in starting current is produced by tapping off the supply to the motor from the transformer. This tapping off reduces the effective supply voltage to the motor. The transformer is connected in star. As the motor speed increases, the tapped off supply is altered. This leaves part of the winding in series with the motor. This acts as a choke, reducing the current. Okay. Okay. Now, here we have a rotor resistance starter. This type of motor can be started up against heavy loads. The control of torque and speed is gained by extending the resistance of the rotor to an external bank of resistors. Okay. And I'm looking for my external bank of resistors. When the start button is pressed, a supply is connected to the coil, and the stator winding has a supply. The contact at B is made, and there is a maximum resistance connected across the rotor windings via the external resistors. When the handle is moved, the resistors are shorted out and contact A is made, and the DOL starter is held on until the stop is pressed or the overload operates. When all the resistance is connected in the rotor circuit, maximum torque is developed at standstill. As the speed increases, the torque drops until it is balanced by the load. Okay? So again, read this for yourself. Make sure you're familiar with it for your own self. Look at additional information on this. Okay? And remember, you must be compliant with the IEE regulations at all times. Nothing overrides that. Okay? Right, let me just check if I'm on the last slide. I am on the last slide. Thank you. Okay. Right. Okay, I hope you found this useful and will find it useful in due course. Okay. Please study, study, study. Have a good day. Bye-bye for now.